Criminal digital forensic investigation application based on blockchain. Abstract. In recent years, blockchain has generated a lot of buzz. Although studies have been conducted on blockchain technology, it still requires more research before it can be fully implemented. By adopting blockchain, the system's decentralized nature will help to increase transparency and make the system safer for everyone. Blockchain is a digital ledger of transactions that is duplicated and spread over the whole network of computer systems on the blockchain, and it is a system of preserving information in a way that makes it difficult or impossible to edit or hack. Blockchain platforms haven't progressed far enough to be compatible with existing digital forensic (DF) tools, methodologies, and procedures. Collecting, identifying, evaluating, analyzing, preserving, and presenting evidence is a difficult task in existing forensics. That's where the blockchain's decentralized nature comes into play, with forensic data being stored in the private network using the blockchain's nodes in a peer-to-peer network. It's also well suited to the Department of Defense's requirements for evidence integrity and provenance across jurisdictional boundaries. Digital forensics will also be more secure, and the investigation will be more transparent to those on the other side of the jurisdictional border, due to blockchain technology. Keywords: digital forensic, blockchain, SHA algorithm, ease encryption, forensic evidence chain. Introduction. Blockchain is the newest and potentially most affordable means to access cloud storage, as many small companies contribute to cloud storage through processing power and storage space. The crypto hash, timestamps and transaction data of the preceding block are contained in each block. Blockchain is a growing series of documents called blocks that are connected together via encryption. The data of users is broken up into small chunks by blockchain cloud storage solutions. Then build another security layer and scatter around the network. This is feasible using blockchain characteristics like hashing, private/public encryption and transaction data, ledgers. Another advantage is that because the node only store the needed information that is required, does not store too much excessive information. The users are only given a portion of the data, so all sensitive information is kept safe and secure. Redundancy of data and load balancing measures are employed to ensure fast access and high availability. Digital forensics is a process of in-depth analysis of digital devices and data within a legal context, such as a criminal investigation or civil inquiry. Crime scene refers to the field where criminals commit crimes, generate and leave crime traces, and evidences within a certain range of time and space. Crime scene analysis is the starting point of crime investigation, thus it is of vital importance to the success of cases solving. 5. In the digital forensics investigation practices, there are over hundreds of digital forensics investigation procedures developed all over the world. Each organization tends to develop its own procedures. Some focused on the technology aspects in data acquisition, some focused on data analysis portion of the investigation. 3. RDF will assist in overcoming many challenges, such as hacking, and will improve the security of evidence collected in the course of a criminal investigation. The evidence is stored in a secure manner, ensuring that no third person have access to the evidence. This technology will increase the system's security by twofold. Literature survey. This paper conducted preliminary forensic research on the blockchain-based forensic investigation framework by considering the diversity of devices, evidence items, data formats, and more in the complicated IoT environment too. The author of this paper stated that cybercriminals steal information from IoT devices and other sources, and that in order to prevent this, they used blockchain technology to create a framework for storing data and preventing it through various methodologies. They only mentioned preventing cybercriminals in the IoT, whereas we propose a framework that will aid in the investigation of crimes such as murder. New tools are necessary to improve IoT forensics, especially because anti-forensic techniques will continue to become increasingly sophisticated. 6. Because the number of cybercriminals is increasing every day, the authors claim that new forensic tools that can handle IoT data are needed. So we're working on a framework that's not for IoT devices, but for assisting in criminal investigations and adding another layer of security. This framework is its coverage. Through this framework, different standards and procedures could be linked together in a more holistic way. Digital forensics investigation is no longer viewed from pure technical aspects. Business, system, and legal aspects are incorporated. 3. The authors have created a comprehensive digital forensic framework that is both business and legal in nature. As a result, I created a completely crime-oriented framework that will aid in the investigation of crimes. Proposed system. This criminal digital forensics will give double security for digital evidences by utilizing hash functions such as SHA-256 and the Advanced Encryption Standard, also known by its original name Rayondale, to generate a hash and successfully form a verifiable evidence chain. Details about evidence identification, preservation, analysis, and presentation will be documented in blockchains. The DFIF will assist in investigating and updating the investigation status more accurately. This project will assist in determining how we can provide or improve the security of the investigative framework. By incorporating forensic investigation and additional information, blockchain technology can overcome the tampering, hacking, and make the investigation more accurate and secure and make data acquisition and validation more accurate and informative. The forensic investigation uses blockchain to build a closed-loop system that provides significant forensic analysis benefits in a timely and cost-effective manner. We are also giving double encryption by using the strong algorithms like SHA-256 and EASE algorithm and store everything in the system, which uses blockchain technology, which will make even secure the storing system, because blockchain have a functionality like immutability. Every information will be stored in the form of blockchain's block and everything is secured, and these will make hard for anyone who try to manipulate the data, how much time the data is being altered or tampered in the application. The original data can be easily recovered. System architecture. In this architecture, the application manager or admin will add important actors to the application, such as police officers with their respective police station name, higher officers with their roles, forensic staff, and medical staff, as well as their details. The user IDs and passwords will be generated programmatically, and those IDs and passwords will be sent to the actors via email, which they will receive after the application manager has added them to the application. For mail purposes, we will use the SMTP protocol, and they will be able to change their passwords if necessary, which will be saved in the database. A police officer will file a first information report, FIR, and update the information in the application if a crime, murder, occurs within their jurisdictional border. The forensic team will gather all of the information and use it to create a report based on their findings. The medical staff will review the information gathered by the forensic team, and if anything unusual occurs, such as a murder, they will generate a report on the death hour, blood splatter, and fingerprints. This information will be saved, and a report will be generated in the application. The higher officers will monitor the crime investigation and can also see the medical and forensic report. Implementation. Workflow diagram. The FIR information from the police stations, the forensic team's report, and the doctor's report will all be updated in the application, and a report will be generated. In the program, these data will be stored in hash format. The data will be converted to a hash using the SHA-256 algorithm, and the hash will be passed to the EASE encryption algorithm, as well as a few other entities. The EASE encryption algorithm will run for 10 rounds before generating a 128-bit key. This key will be stored in the form of a blockchain database. EASE algorithm. EASE is symmetric key cryptographic algorithm published by MST. The algorithm was proposed by Rayondale. It is also known as Rayondale encryption algorithm. EASE is a day replacement. The block cipher technique is used by EASE. Plain text and cipher text must be the same size. The size of an input key is the same as plain text. EASE supports data lengths of 128, 192, and 25 bits, as well as 3 different key lengths of 128, 192, and 256 bits. IJERT is made up of several rounds of processing different key bits, such as, encryption is performed 10 times with a 128-bit key. The 192-bit key performs 12 encryption rounds. The 256 hits key encrypts data for 14 rounds. IJERT algorithm steps. Byte substitution, sub-bytes. The 16 input bytes are substituted by looking up a fixed table, S box. The result is in a matrix of 4 rows and 4 columns. Shift rows, each of the 4 rows of the matrix is shifted to the left. Mix columns, each column of 4 bytes is now transformed using a special mathematical function. This function takes as input the 4 bytes of one column and outputs 4 completely new bytes, which replace the original column. The result is another new matrix consisting of 16 new bytes. It should be noted that this step is not performed in the last round. Add round key, the 16 bytes of the matrix are now considered as 128 bits and are XORed to the 128 bits of the round key. If this is the last round, then the output is the cipher text. Shift right, SHA-256 works on bits ones and zeros. All data can move represents in bits, and it operates on chunks of 32 bits, which we refer to as a word stated, a word of 2 bits. Shift right, it shifts the bits over a number of position, that's a 32 right, a 32-bit shift. Right rotation or rotation right, similar to a right shift. Instead of shift in the bits off until it never come back again, it moves them over onto the left-hand side to create this rotational bitwise operation or circular right shift. Exclusive OR, it produces 1 if one of the 2 bits you've been put into it. It gives balanced representation of the bits. Padding. Before stating an hash function, we need to do padding because hash function likes to hash data in chunks of 512 bits at a time, so this is only 24 bits of data. We need to pad it out with zeros basically to make it 512 bits. We need to append 1 at the end of the binary string. Conclusion. Because forensic reports are an important part of crime investigation and evidence collection, we are securing them with the Rayondale algorithm, SHA algorithm, and blockchain technology. The details of the crime forensic report are sent to the police department in a secure and authenticated manner, which will aid future criminal investigations. The goal of this study is to create a blockchain-based DF investigation framework environment that can enable forensic investigation with high authenticity, immutability, and traceability between evidential entitlements and examiners. The application is tamper-proof, so that forensic report is highly secured using blockchain technology. We've used more secure algorithms in this application to make it more secure. The application will become even more secure and powerful as a result of the blockchain technology.